Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are looking at a circuit question that does not have internal resistance. Now, if you look at the sum, it says in the circuit provided, the potential difference of the battery is 12 volts. So here we have a 12-volt battery, and it says ignore internal resistance. Now, the moment we see ignore internal resistance, we'll see that we don't have to use the EMF and the lost volts and etc. etc. So that will make our life easier. Now, let's look at the question. The first question is calculate the total effective resistance in the circuit. Now, if you look at the circuit, we did an earlier video clip where we saw that when we have a combination of resistors, there's a way of working out the total resistance in the circuit. So here we see we got a 1,4 ohm resistor, which is in series to this whole parallel component, which is 2 ohms, and this whole branch, which is 5 plus 3, 8 ohms. So if you want to work it out, I'd say what we can say is work out the parallel branch first. 1 over Rp is equals to 1 over 2 plus 1 over. Now here, because these two are together, we can say 5 plus 3 is 8. So it becomes 1 over 2 plus 1 over 8. And if we calculate this, that's 8. And then this will be 4 plus 1 over 8, which becomes 5 over 8. And that's 1 over Rp, which actually becomes 8 over 5. We must remember that we have to swap it around, and then this becomes 1,6 ohms. So that will be the effective resistance of the parallel part. So our total resistance will be made up of the 1,4 ohm resistor, which is in series to the whole parallel component, which is 1,6 ohms, and we can see 1,6 plus 1,4 will give us a total of 3 ohms. So the total effective resistance of the circuit is 3 ohms. Now the next question says calculate the total current in the circuit. Number 2, so if you want to work out total current in the circuit, I total is equals to V total over R total. So that's what we can do. We can work out all the totals. If we work with the proper aspects with each other, then it makes our life easier. Our total voltage in the circuit is 12 volts, and our total resistance, we worked it out in the sum before, which is 3 ohms, and 12 over 3 will give us a total of 4 amperes. So our total current in the circuit is 4 amperes. And I just want to mention here, we see that to work out number 2, we used the answer in number 1. And many times in circuit questions, they do that, where the answer in question 1 is 3 ohms, and we needed that answer to work out question 2. So say we are stuck with a certain number 3, sometimes a clue can be found in number 2 and number 1 above. Okay, going on further. So if you want to continue with the sum, the number 3 says, what will be the reading on V2? Now this is very important, that if you look at V2, the total voltage is 12 volts. And many a times we find learners also say, assume that V2 is 12 volts, but that is not the case. V2 is only connected across the 1,4 ohm resistor. So we can say V2 is equals to, V is equals to I times R, and I'm going to put a small r there to show that that will also be not the total resistance, it will only be the resistance that V2 is connected across, and V2 is connected across the 1,4 ohm resistor. So if you look at V2, the current going through V2 is all the current, because the current comes down the circuit this way and all the current will be going through. So all the current goes through, and the current is 4 amperes. We worked it out in the sum before. Again, we see that we needed the sum before, 4 amperes, and the V2 is connected across the 1,4 ohm resistor. And if you work it out, 4 times 1,4, we get 4 times 1.4, we get 5,6 volts, 5,6 volts as the potential difference across V2. So that will be 5,6 volts. Right, going further, question 4 is quite an involved question where it says what is the reading on V3? So we have to work out the reading on V3 here. And obviously it cannot be 12 volts and it obviously cannot be 5,6 volts. So this will be an interesting sum to do. So to attempt the sum, we see that if you look at V3, there are certain things that we need to know here. So if you look at number 4, let's look at it. To work out V3, we have to know the current and the resistance going through the 3 ohm resistor. So we don't have the current going through the 3 ohm resistor, and we have the resistance of 3 ohms that are there. So if we can work out the current going through the 3 ohm resistor, then we can work out V3. Now, we don't know how to, we don't have sufficient information as yet to do that. But let us see what we can do. We can maybe work out the potential difference across the whole circuit. So to do that, we can say VP, voltage in parallel, is equals to I times RP. If you look at all of these sums, I is equals to V over R, V2 is equals to IR, VP is equals to I times RP, they are all V is equals to I times R. They're using that same equation. However, what I'm trying to do is to show you that if we add subscripts, it will make our life easier. That if you are working with I total and we work out V total and R total, then it goes together. If we want to work out voltage in parallel, we take our total current, which is 4 amperes, and we take our combined resistors in parallel. And our combined resistance in parallel we found to be 1,6 ohms. And by doing this, we can work out our voltage in parallel. So that will be 4 times 1.6, and that's going to give us 6,4 volts. So now we know that the voltage in parallel is 6,4 volts. So the voltage here is 6,4 volts. Now, if I have the voltage in parallel, that means the voltage on the top branch is 6,4 volts, and I've got the resistance. Can I work out the current going through here? Yes. So let's work out the current going through the top branch. So I is equals to V over R. So the voltage in the top branch will be 6,4. Again, be careful that you take the right information and pair it off together. The voltage on the top is 6,4, and we see that it goes with a 2 ohm resistor divided by 2, and the current going through there will be 3,2 amperes. So we know that the current going through the top branch is 3,2 amperes. Now taking it further, we can see that if the current going through the top branch is 3,2 amperes, then therefore the total current is 4 amperes, and the current going through the top branch is 3,2 amperes. Therefore, the current going through the bottom branch is 0,8 amperes. And now we have worked out the current going through the bottom branch. So looking at our diagram, we've got our current going through here as 0,8 ohms, 0,8 amperes. So current is 0,8, and your resistance of the V3 will be 3 ohms. So we can work out the voltage of V3. So we can say therefore V3 is equals to I times R. And our current going through V3 is 0,8 amperes, and the resistance of the resistor is 3 ohms. So we can say that is 3 ohms, and 0.8 times 3 will give us 2,4 volts. So that is how we will go about calculating the reading on V3. So the reading on V3 will be 2,4 volts. And they didn't ask it, but we can see that the reading of the 2 ohm resistor is 6,4 volts. So the reading at the bottom must also be 6,4 volts. And if the reading of V3 is 2,4 volts, then the reading of the 5 ohm resistor will be 4 volts. 4 plus 2,4 will give us 6,4. And then also we can say that 6,4 plus 5,6 will give us a total of 12, where our total volts is 12, which is broken up into series by the 5,6 volts, which is V2, and the voltage in parallel, which is 6,4. So this is a typical sum that we can understand where no internal resistors is involved, and it is an important sum in order to understand work related to calculations relating to electricity. Thank you very much for watching.